So let's quickly look at electromagnetic radiation math. Let's recall what electromagnetic radiation is. It's a wave, and because it's a wave, it has a wavelength, a frequency, and a speed. In this case, the speed is the speed of light, because EM radiation is light, and we use this symbol C, and its number is actually 3 × 10⁸ meters per second. Frequency has this symbol, nu, and its units are 1/2 or a hertz. Wavelength has this symbol, it's lambda, and its units are in meters. This is very important. A lot of times the numbers will be given in nanometers or micrometers, and you need to change them into meters. Let's see how that's done. So this equation was one you actually created already. You found velocity here, which is, in this case, the speed of light, is equal to lambda nu, wavelength times frequency. So, what is the frequency of electromagnetic radiation with a 500 nanometer wavelength? So, looking for frequency, given wavelength must be in meters. So, we need to transfer that into meters. 500, and I'm going to go ahead and put a decimal here. Let's make it 3 sig figs nanometers. You will recall there's 1 × 10⁹ nanometers in 1 meter. And when you do that all the way out, you get 5.00 × 10⁻⁷ meters. That is your lambda. You're looking for nu. So C equals lambda nu. C is always 3 × 10⁸. Lambda in this case is 5.00 × 10⁻⁷. And you are searching for frequency, which is nu. Divide both sides by 5.00 × 10⁻⁷, 5.00 × 10⁻⁷, and you get 6.00 × 10⁻⁴ hertz. Sig figs wise, you have 3 here, you have 3 here. This actually did have 3.00, but it's also a constant, so we do not care about its sig figs. Whatever you start with really should be what you end with in these equations. So that's how you're going to use C equals lambda nu. Given wavelength, find frequency. Given frequency, find wavelength. That's it. So let's go down and let's look at another relationship. Energy is proportional to frequency. We saw that in the quick card lab. We didn't define everything, but energy is measured in joules. You're probably used to it being measured in calories, but in physical science we like joules. This H is a proportionality constant, and it is a constant, so it's just a number that you're going to insert, and I will provide this number for you. Its units are joules times seconds, and you have frequency in hertz or 1/seconds. So here's your equation. Energy equals H nu. What is the energy of EM radiation, whose frequency is 4.15 × 10⁻⁴? So E equals H nu. E equals 6.626 × 10⁻�34. You do not have to write the units in. I think they kind of get in the way right now, so leave them off. Times 4.15 × 10⁻⁴. And that's it. Stick it in your calculator, and the answer is 2.75 × 10⁻⁻19 joules. That's it. You have energy. So up to this point, we have 2 equations. We have E equals H nu and C equals lambda nu. The question is, can we find a relationship between E and wavelength? And the answer is yes, because they have frequency in common. So I'm going to rearrange this equation to be C over lambda equals nu. This thing right here, I'm going to sub in here. So when I do that, let's see if I can make some room. E equals H C over lambda. So this is actually our final equation. This equation, and this equation were basically given to us, and we kind of discovered these in that card thing. This right here, we just derived. So we have 3 equations for this unit. So let's go and look at what the problem would look like. What is the energy of EM radiation whose wavelength is 650 nanometers? Let's go ahead and put a period there so it can be 3 sig figs. Energy is equal to hc over lambda. You do not have to do the parentheses. It's actually hc divided by lambda, no parentheses, but I'm trying to keep it separate so you can see it. What is the energy? 6.626 times 10 to the negative 34. 3 times 10 to the 8 divided by, nanometers. Let's change that real quick. 650 nanometers, 3 sig figs. 1 times 10 to the negative, 1 times 10 to the 9 nanometers in 1 meter. That's 6.50 times 10 to the negative 7 meters. So 6.50 times 10 to the negative 7. Put these all in my calculator. I'm not going to do this in my head. Energy is equal to 3.06 times 10 to the negative 19 joules. And what this is, and the energy up above, is the energy of a photon, of 1 photon of light.